For many of the geometry problems that you're going to be working on, there are lots of equations that you're going to need to know. So let's talk about a square. We all know what the area of a square is, right? Let's say the length is x, right? X by x. Then the area of that square is going to be x squared, right? X times x. If you have a rectangle with a width of w and a length of L, the area is going to be length times width. We all know that one as well. If we have a triangle, we should remember this, although it might be a little bit less well known. You have the height, so a straight line from the top to the bottom, and then you have the base, right? Just the width of the bottom. The area of a triangle is going to be your base times your height divided by 2. Okay, so that's another one that's important to remember. If you have a trapezoid, something like this, you could say, all right, well, here is your height. You have a base, and you have this length on top. We'll call that A. The area of a trapezoid is going to equal A plus B times H divided by 2. So we frequently call this a trapezoid. You might hear people call it a trapezium. There's different words to describe some of these shapes once you get into the odder ones, but that's okay. Let's talk about a parallelogram. So something like this. The sides are parallel, right? You could say that, okay, we have a height here, right? That's your height. And you also have a base. And that base is going to be the same length as this base on the top. It's the same length. I shouldn't call the top the base is on the bottom, but they're the same length. The area is simply equal to base times height. Which is kind of funny, right? It looks like a rectangle. It's kind of been slanted a little bit, so it keeps the exact same area, right? So base times height. What about a rhombus? What is a rhombus? A rhombus is something that looks like this. You might have heard it called a diamond when you were younger, but basically you have a height. So from that top peak to the bottom, just like that, that's your height. And you also have the length. So from here all the way across to there, so from one point to the other, that would be your length. The area of a rhombus is length times height divided by 2. Okay, let's talk about circles. So if you have a circle and you want to find the area of a circle, what defining feature do you have? Well, you have the radius. The radius is the length from the middle of the circle to the outside edge of the circle. So you could say your area is equal to pi times r squared. You say, what's pi? Pi is a special number that describes the relationship between the radius and the area. Or really, it describes the relationship between many different characteristics of a circle and its radius. Another example would be if you want to find the perimeter of a circle, that's what's known as the circumference. We call that c. That's equal to 2 pi r, which is equal to pi times d, because 2r is equal to d. d, of course, refers to your diameter. Diameter is the length from one side all the way to the other. So this whole length would be your diameter, but just half of it, from the middle to the outside, is your radius, r. So you could use either one. What if we have something like this? And I'm going to draw some axes just to help us stay organized here, because my drawing will get a little bit messy. This is what we call an ellipse. It kind of looks like a football, right? It's actually sort of like a squashed circle, right? Like the circle got squished a little bit and it got pushed out in both directions. So when you think about the radius of a circle, the radius is the same whether it's going like that or like that or like that or like that. The radius is the same. But if you look at an ellipse, the radius is different if it goes up versus if it goes like this or like this. It'll be different lengths, right? Because this thing is not symmetrical in every direction. And so there's two sort of radii or radiuses that we can talk about. There's this little value here, a, from the middle to the top, and then there's this longer length here, b, from the middle to the outside over here. And the area of the ellipse will be equal to pi a b. Now if you're curious as to what the circumference of an ellipse is, because of course we have the equation for the circumference of a circle, we should also have an equation for the circumference of an ellipse, or the perimeter of an ellipse. Unfortunately, there is no 100% accurate equation for the perimeter of an ellipse. There are some estimations out there. People have put together very complicated looking formulas that claim to be relatively accurate in finding the perimeter of an ellipse, but none of them are 100%. It doesn't exist, unfortunately, or it hasn't been uncovered, maybe you could say, but no, it's believed that you can't find it exactly. There's no one equation that will give you the exact perimeter. So unfortunately, we don't have that. Now, when it comes to finding the volume of a shape, right, a 3D shape, all you have to do is find the area of the cross-section and multiply it by the length of the shape. Now, we can find the area of any cross-section just based on all these equations that we just talked about, right? Whether the cross-section of your shape is a square, a trapezoid, a rhombus, a rectangle, a triangle, a parallelogram, a circle, or an ellipse. It doesn't matter. You find that area and you multiply it by the length of your shape, right? So let's say you had a prism, right? A rectangular prism. And this is rectangular. Actually, this one looks a bit like a square, but say it's just a rectangular prism where your base here, your cross-section, is a rectangle. You find the area of that and then multiply it by the length. And that gives you the volume. If you had a triangular-based prism or a triangle-based prism, you find the area of this triangle, multiply it by this length, and that would give you the volume. If you have a cylinder is kind of like a prism, but it's got a circular base, like that. It's not the best drawing, but you can imagine what a cylinder looks like, right? It's like a can of Pringles or something like that. You find the area of the circle, and then multiply it by the length, and that would also give you the volume. So when it comes to finding the volume of shapes that have a consistent cross-section, like these ones, I say consistent cross-section because whether you take a slice here, or you take a slice, over here, those are going to be the same area. It's the same area all the way through for all of these shapes, right? If you look at the area here in the middle of the shape, it's going to look exactly the same at every stage of the shape. All the way through is the same. Same with this one. There are some 3D objects that are not consistent with their cross-section, like pyramids, cones, spheres, things like that, where it's not just a face that continues for a certain length. And for those ones, you have to use their own specific formulas to find the volumes. But for shapes like this that have a consistent cross-section all the way through, you just multiply the area of that face by the entire length, and that gives you the volume. Now let's talk specifically about some of these shapes that don't have consistent cross-sections. Let's say I have what we would call a cone typically. So it's got a circular base like that. It's kind of like a pyramid, but the base is round, but we would call that a cone, right? So there's a couple dimensions here we could find. You could find the height. So from the floor all the way up to the top, that would be your height. And you could also find the radius of the circle. So from the middle of the circle to the outside, that's your radius r. The volume of a cone is equal to pi r squared times the height divided by 3. It's kind of an interesting equation, but that represents the volume of a cone. Now let's talk about a pyramid. If you have a pyramid, it means that you have a base that's either a rectangle or a square, something like that, and you have all these sides coming up from corners like this. There's your pyramid. It's not the best drawing in the world. I've tried this a couple times. I struggle to draw it. That's okay. You have a length for your base, right? This length, and then you have a width. It could be different because that could be a rectangle, could be a square, we don't know. And you have a height. The height is the length from the very top to the floor, right? That's your height. Okay? The volume of the pyramid is equal to the length times width times height divided by 3. Kind of similar to the cone, right? You can see the similarities. The cone obviously uses pi in the radius because the bottom is a circle, whereas this base over here is a rectangle, so they use length and width. But other than that, they're pretty similar. Okay, what about a tetrahedron? What's a tetrahedron? Tetrahedron. This is what you may have heard referred to before as a triangle-based pyramid or a triangular-based pyramid. The fancy name for it is tetrahedron. So basically, you have a triangle as your base, and then, it really looks like a pyramid, although pyramid usually means four-sided base. That's why they call this tetrahedron. Now, we got some information here. We have the height, which is the distance from the peak to the floor. So I'm going to actually draw that out here like this. So you have your height. And then on the inside here, on your bottom, on the base, you have this length y, and you have this length here. We'll call that x. And if you imagine the base as just a triangle, so if you just drew the base, and you had the y, you had the x, it's kind of like the base and the height, right? So this is the the face on the bottom. This is the foundation of the shape. Okay, so now for this one, if you want to find the area of the base, call that AB for area of the base, it would be x times y over 2, right? Base times height over 2. You could then use this in the volume equation for this thing, right? Because as we've kind of seen a pattern here, right? The volume of all these sort of triangular shapes, whether it's a cone or a pyramid, is just the area of the base times the height divided by 3. So the area of the base times the height divided by 3. You could sub that in and say x times y over 2 times h over 3. Well, what's this going to become? It's going to become x, y, h over 3 is your volume. So that's the equation you could use. This is just a little bit of the behind the scenes of that, right? Because again, every one of these triangular looking shapes that kind of look like a pyramid, it's just the area of the base times the height divided by 3. If you go back up here, for your pyramid, you have the area of the base, length times width, times the height divided by 3. For this one up here, you have the area of the circle, pi r squared, times the height divided by 3. Same exact thing that's going on down here. So once you see these patterns, it allows you to, make assumptions and figure out areas of new shapes that you could come across, right? Okay. Now, for the last one, let's talk about a sphere. So a sphere is like a ball, right? So you have a ball, and on the inside of the ball, in the middle, you kind of have this circle, right inside it, right in the middle. And from the middle of that circle to the top would be your radius, and that's the same length as if you went out to here, as if you went to here. Doesn't matter. Anywhere from the middle of the sphere to the outside edge of the ball to the outside edge of the sphere is going to be your radius. Those are all the same. So I'm just going to draw it like this for in general. Okay, that's my sphere. The volume of your sphere is going to equal 4 over 3 pi r cubed. 4/3 pi r cubed.